Hello, my name is Antonio Mele and I'm the Deputy Undergraduate Program Director at LSE, and in this presentation I want to talk about the implementation of Gradescope, a platform for marking feedback in our economics courses. So first of all, a bit of information about why we have started to use this platform at LSE. So there is a high admin burden with the process of giving feedback and marking formative coursework at LSE, and therefore we were trying to find solutions to reduce this high admin burden and to give the possibility to our students to receive more feedback. The other main issue was consistency across marker. We mainly have large courses, particularly in our first and second year of the BSc in economics, in which there are many markers, and it becomes very difficult to guarantee consistency of marking and feedback across all these markers. The other reason is that our LMS, which is Moodle, has a marking system, but it's not ideal for quantitative papers. So we wanted something that was more already designed for quantitative papers, marking and feedback. And Greatscope seems to be one of the platforms that satisfy all these constraints. So we adopted Gradescope in most of our courses. So let me tell you a little bit about Gradescope before we go into the analysis of the implementation. So Gradescope is this platform, and I would say the main purpose of this platform is to be used for marking and possibly giving feedback to students in quantitative subjects. So here you see an example of computer science, you see math, physics, but of course economics is another one. One of the main features of Gradescope is that it allows you to create a rubric for marking your scripts dynamically. So that means that you can add items to this rubric as you go through the marking process. So you realize there are some common mistakes that the students are recurrently making. You can add an item in your rubric that cuts point, for example, for that specific mistake. You can do it as you go through the scripts. The other feature is that you can change the deduction points for each of these items even after you have marked already several scripts, and immediately this will be automatically applied to all the scripts that have been making that mistake, in which the marker has assigned that item. The way in which this rubric will work in assigning mark is that you just click on the item, and that means you have assigned that deduction to that script. Or you can use keyboard shortcuts. So for example, this item here as a 2 as a keyboard shortcut. So if you click the 2 on your keyboard, you assign that item to the script as a deduction in terms of the mark. So this is a very easy way to mark. You create item as you go through the exams. You can easily assign them in a very simple way. There are other features that are very appealing. Mostly is the digital submission can be done by the students or can be done by the instructors, the lecturers, the TAs. So it is really flexible in the way in which you bring the scripts to the platform. The other thing is that it's very easy to get information about how the marking is going. So for example, let's say there is a specific mistake that you feel many students have been making, and you realize maybe it's because the question was particularly difficult, so you were cutting 2 points for that specific mistake. You check that this is a very common mistake, and maybe you realize maybe cutting 1 point is probably the right thing. But you can immediately see all the scripts that have be marked with that item in your rubric and get a feeling of how that mistake is propagating through the cohort. This also allows you to adapt your teaching to that specific mistake if you feel that is a common mistake in your classes. It has a system of statistics, so that's very helpful. You can also have statistic question by question, so that's also quite useful for us. The other thing that Gradescope is pushing now is the possibility to use AI assisted grading, in which an AI algorithm will group similar answers for a question all together, and then you have to mark that group of answers only once. So this works. I want to say we didn't try it in our courses, but we plan to experiment with it, but it will work if the answer is concise. For our questions, usually the answer is several lines of calculation, a diagram, and then some written words, so that might be a little bit challenging. So these are the main characteristics of this platform. Let me tell you a bit about what we did at LSE. We implemented in most of our courses, not all of them, and most of our courses in the undergraduate program. Mostly in the first and second year courses, which are particularly large courses. We go from around 150 to around 900 students in these courses. We also had some lecturer using it in smaller courses, in third year courses, and someone in the master was also adopting it. The idea is this will streamline the process and will make it easier and faster, and will make it more consistent. And one of the main results that we have from this implementation is that all the instructor and teaching assistant report a dramatic reduction in the time they have to dedicate to this, and a more effective feedback for the students. So we conducted some interviews after the implementation with class teachers and course manager. Course manager are coordinators of the class teachers that large courses have, exactly because of this problem of consistency across delivery and marking. As I was mentioning, what we find is that the Greatscope platform is improving the experience of our class teachers and the course managers. In particular, the real big advantage comes from the rubric. Having this rubric and use it across markers simplifies their life, and it makes it easier for them to give feedback to the students. In particular, we discovered that letting markers create their own rubric item is not a great idea. It is better that one person, say the lecturer or the course manager, creates a rubric that is general enough, and then markers apply it, and maybe have a little bit of customization for each student by leaving comments on their script. So this is the best workflow for us. That's what it worked. When we left markers free to choose their items on the rubric, it was really a nightmare. It's the grading is more consistent than it used to be, and as I was saying, markers like to use individual comments to customize the feedback to the students. But the marking per se, the mark that is given to the student is more consistent across markers. In general, I would say it was a resounding success. We think that the implementation went through a series of experimentation, and we think the best workflow now works in this way. So deducting points, creating a rubric that deducts point is not a good idea. It's much better to have a rubric that adds points for each correct statement. The other thing is that we need to have a detailed rubric. It doesn't have to have 1 million items, but it needs to be detailed enough to make sure that it's easy to apply for our markers. The class teachers also need training and guidance on how to apply the rubric or how to improve it if necessary. and also how to use these personalized comments that I mentioned before to personalize their feedback to the students. Overall, I think there are a lot of pluses in this implementation. There are some missing feature in Greatscope. So here is a short list, and we have been liaising with the provider about those. In particular, one is the locking rubric. There is no way to lock the rubric once you have created, and this created a lot of issues at the beginning because markers did not understand that deleting one item in the rubric means you are deleting that item for everybody else, and in particular you're deleting for scripts to which that item has been applied. So those students end up without having a mark. So we are liaising with the provider, and they are very flexible in this, I would say. So that's a good thing. So let me conclude by saying this was a big success, and we recommend this platform to other institutions that want to that have similar problems in terms of consistency and admin burden for the markers. And we think there is a strong potential for using this for summative assessment, but the main issue there will be how do we bring quantitative scripts to the platform, and there are different possible ways to do it. However, we're still discussing it at LSE.
Hello, everyone. I'm going to be talking about improving student comprehension through interactive model visualization, which is a joint project with Chris, Doug, and Anastasia. Now, the main basis for this is a website called econgraphs.org. Please go there and take a look at the fantastic interactive graphics there that are provided free of charge, without cookies, no data stored, by Chris Mackler. I really recommend you go and look at those and see the interactives that we're talking about, because they are the basis for our presentation. Now, what have we done? We've basically taken these interactive exercises, embedded them in problems that we get the students to solve, and we ask them to play around with the sliders, which you can see over here, and we'll see how the figures move around when the sliders change. We ask them to check their understanding, make a prediction, make sure that they were right, or check if they were wrong, and then also check the algebra. So that's the kind of exercise that we have, and we also have a variety of exercises. We're basically 20 of these that we're going to be able to share at the end of the project. So why would we do this? There's a variety of bases in the literature for this. Basically, students have misconceptions. They also struggle with models. And if you can get students to basically practice with interactive models, that can get novice students to become slightly more like people who have mastery of a topic. And that's the motivation for why we would think about this. So what have we done? We've got these 20 interactive exercises that I spoke about. We have them in 3 different institutions, where they were used in either problem sets, pre-class quizzes, or in-class exercises and tutorials. And then we surveyed students about their experiences. So what are the institutional specificities? Well, we have our 3 institutions, 2 in the US, Institution A and Institution B. They have about 100 or so students in a few different classes. At Institution A, just for intermediate microeconomics. For Institution B, there are 2 parts of intermediate microeconomics, microtheory 1 and microtheory 2. Institution 3 is an institution in the UK where there were not quite 500 students taking the second half of intermediate micro. And those are the 3 places where we fielded these interactive exercises. Now, our student feedback is as follows. I'm going to show you some graphics depicting their average results, and then I'll talk about some additional results from Institution A alongside some student comments. So at Institution A, when we asked them how helpful they found it, basically the majority of students found them somewhat helpful or very helpful. Then we have comments about their helpfulness, where a student says, the interactive visualization exercise helped me better understand the material because I was able to take the concepts that I just learned and see it put into play with the problems. I could also write down what would happen in the simulations problems. Another student who wasn't so positive said, not sure. I don't find the visualization particularly helpful, but I also tend to be a less visual person. I could see how these types of exercise would be helpful for other students. So very importantly here, you're going to see students sometimes self-report as being more or less mathematical. A student who reports being mathematical basically tends to think that the interactive exercises are not as helpful to themselves. At institution B, we've got the two different courses, there's a Likert scale, and in micro 1, we see that the majority of students for all three modes, readings, lectures, and quizzes, reading, quizzes, and lectures, basically finds these exercises helpful. And the same is true in the second class. I just want to show you those before I go back to the comments. Again, most students find them helpful. Slight change though, with not quite as many students finding them helpful. And some comments. I thought the pre-class quizzes allowed me to be more prepared for class and get a better understanding of the material because it was the second time seeing it. I liked the interactive ones with the graphs because I liked how you could visually see the changes. Another student said, yes, it's super helpful to see a change in real time rather than trying to juggle all the concepts mentally. Made this so much more enjoyable than Economics 1. And that's something we see echoed in Institution C, where students basically were really finding them helpful when there were many variables involved and they needed to be able to separate them. So on Institution C, again, Likert scale reporting, 3 different cases, exercise lectures, the interactives used in the e-textbook, which is where they were embedded, and then tutorial solutions. The students predominantly saw them in the exercise lectures and the tutorial solutions, and that's where we implemented them with these exercises in addition to them. So one student said, interactive graphs can sometimes be useful in visualizing shifts, but I find it easier to understand by looking at equations. That was a student who said they were very unhelpful. So that student said, not helpful at all. Another student who said was neutral. They said, I tend to understand the equations of the curves. I don't find the interactive graphs very useful. And then a variety of other students said that they found them very helpful. So a comment I'm going to focus on here is the third one, where they said the exercises where lots of questions were asked on one graph helped get a large overview and understanding on each line and interpretation of the graph. So there, when there are many parameters in a model, a student really likes seeing how those different parameters can change and how that affects, say, the equilibrium in the model. So these interactive figures allow the student to test that, check their understanding, and make sure that they can then see how this works in the mathematics afterwards. And so that's how we're recommending that folks use them. Now, we have additional data from Institution A, and we hope to get the additional data from Institution C as well once some other things are finished up. But with this at Institution A, we also have additional data on the Mathematics for Economics Skills Assessment and the Principles of Economics Assessment for Microeconomics, 2 additional assessments that the students did in the course. And we basically asked them their level of agreement with 2 statements about their attitude towards economics. I think about economics events I experience and witness in day-to-day life, and I think economics is interesting and applicable for people like me. Now, our dependent variable here is whether a student liked or found helpful these interactive figures. So 3 things I want to draw your attention to here. Over here, we see that the intermediate mathematics assessment is a marginally negative predictor here. Similarly for the micro, in terms of a student reporting that they like it. Now, what does this mean? It means that a student who got a lower grade found them more helpful. So they found the interactives more helpful if they did not do so well in the assessments. This goes back to this question of students who are self-identifying as less mathematical. They're not reporting them as being as helpful. And then a student who found them applicable to day-to-day life, economics that is, also is somewhat marginally more likely to report that these are helpful. So the results there, 3 of them, neither gender nor underrepresented minority status have statistically significant relationships with the student's attitude toward the interactive exercises. The assessments of the prerequisite skills are marginally significant predictors, and students who score lower on those tests are more likely to appreciate the interactive exercises. And then finally, believing economics is applicable to day-to-day life, that's a marginally significant predictor of appreciating the interactive exercises. So some main takeaways and then the path for our future research. Firstly, students find that working through the exercises, they find that to be very helpful on average. So it's either somewhat helpful or very helpful. The majority of our students are finding that in all 3 contexts. There's somewhat more neutral responses in the UK, but we also think that maybe our UK students aren't quite as superlative as the people in the States. Now, another thing is that students who enter the course less technically prepared in particular find the interactive graphs valuable. Right, so those students who are less mathematically prepared or not as prepared from after intro micro, they're finding them more valuable. We also don't want to overinterpret the results where some students find the graphs unhelpful or unneutral. That's just their own subjective reporting for their own experience, right? So many students are finding them helpful, but that if one student doesn't find them helpful, doesn't mean that they don't think that other students might find them helpful, right? And we also know that there's some evidence that students that are more intrinsically motivated to study economics appreciate the value of the exercises more than other students. Now, what's the direction we want to go here? There's three things that we want to think about. We want to estimate the effects of interactive exercises on student learning. We want to investigate the effects of interactive exercise on student mindset and belonging. And we also would like to develop interactive exercise for introductory courses and advanced electives in the future. The more urgent one is introductory classes there, because students in the introductory class, if they also arrive less mathematically prepared, and then we can deal with that or ameliorate those effects through the use of interactive exercises, that might dramatically help those students who might not otherwise just choose to continue with an economics major into the intermediate microeconomics classroom. And then when we again use the interactive graphs, we could be helping those students a second time. So that's what we're thinking about here. And I would strongly recommend that you go to econgraphs.org, that you play with those figures, see how they work, see if you can use some of them in your own teaching, and think about using them in your classes, and maybe even joining our project if you would like to try and evaluate their use. Thank you so much.
Hello, I'm Matthew Olczak from Aston Business School.
And I'm Chris Wilson from Loughborough Business School. Welcome to our presentation on gamification.
So as I'm sure you know, games and experiments have become a commonly used teaching tool in economics. Furthermore, there's now a range of empirical evidence that shows that these activities can be beneficial for student learning. Traditionally, these games and experiments were conducted within the classroom using paper and pen, and sometimes traditional playing cards. However, more recently, a range of platforms, both available for free and also to buy, have been set up that enable these games to be run online. However, there's still very little evidence on how the different delivery formats of these games can impact on students.
So to help fill this gap, we're going to use a case study with an example game and run it across 3 different formats and compare its different effects. Firstly, as a variant of the traditional delivery format, we're going to use polling software in the classroom, in person. And then second and thirdly, we're going to use an online platform technology. First, we're going to do that in an asynchronous remote context. Second, we're going to do that in the classroom using the online platform, but actually in an in-person context. Then we're going to evaluate it, the different formats across several different dimensions, including participation rates, engagement levels, in-game decision making, and student satisfaction through a survey response. The game itself is going to be quite abstract, based on a research paper by Kaplan et al., but it's useful in demonstrating several different behavioural biases. Specifically, students are going to be asked to pick out from a range of options the highest value option under a very tight time limit. So for example here, we'd have to choose between these 4 options, which one of these has the highest value, and number 2 is the answer here with a value of 14. Typical results will show a variety of things. So under the tight time pressure, students are typically inclined to pick an option towards the top of the list. That represents the primacy effect. And students can also be disproportionately attracted to picking options with a large number on the left-hand side here. That's the left digit bias. And by changing the format of the questions, the time limit, and the number of options, for example, we can show how these decision features, environment features, can actually influence the size of these biases. These lessons are really useful for the instructor to highlight several different issues in relation to marketing, pricing, in regulation, in a variety of related settings, including search engines or price comparison sites, or just the general presentation of pricing. So our experimental approach is as follows. We conduct the experiment in three settings that are otherwise identical, but under these three different formats. We run them in a second year undergraduate module, where in the first year we do that traditional polling format, and then in later years we use the asynchronous and the platform face-to-face format. To give you a better idea of the different formats, on the left-hand side here we have the polling version. This is where students in the room use their cell phone or mobile phone as a device to input their answers to the different questions. You can see an example here with a countdown here. But on the right-hand side, this is the online platform. So here we wrote our own version of the game in Class X. It's very similar. As you can see, there's a countdown, there's the different options, but crucially in the online platform, students can progress through the questions at their own pace rather than doing it at the same time as everybody else, as would be the case with the polling software. After each experiment, we ask students to complete an anonymous survey with equivalent questions. And our whole premise here, it rests on the fact that the students are sort of comparable across the different years. We think that's a reasonable assumption in our case because we've avoided the main disruption of the pandemic and because many of the statistics for the different cohorts were comparable, such as module exam results and entry tariffs.
So in terms of our results, our first important set of results concern the in-game decision making within the experiment. So how did the students actually answer these questions? And what we find is that the way in which they tended to answer them in each of our treatments was broadly or actually highly consistent across each of the different delivery methods. And in particular, we were finding evidence of the types of behavioural biases that Chris talked about earlier across all three delivery methods. So this is an important finding because what it means is that the intended learning outcomes, what we want the students to actually get out of the experiment, can be achieved under each of the different delivery methods. Next, we have results on student participation in the experiment. So this table here shows us the proportion of the students on the module that answered at least one question during the experiment. And what we see is that these participation rates varied from 44 up to almost 52%, and crucially were highest for the two in-person formats. Next, for these students that answered at least one question during the experiment, we can work out what proportion of the questions did they answer. And what we see is that in general, this average response rate was high, but crucially, it was highest for the asynchronous and platform face-to-face treatments. In other words, this was highest for the two treatments that used the platform, possibly because students were able, in both of these treatments, to work through the questions in their own time. Using these two pieces of information, the next thing that we can work out is our measure of engagement. So this is the average proportion of the module cohort that completed a typical question. In other words, it's the average response rate multiplied by the participation rate. And if we work this out, this is what we get. So crucially, what we see is that engagement was highest for the platform face-to-face format. Next, we have the results from the survey that students were asked to complete after the experiment. In this survey, we asked the students, did they think this was a more fun way to learn? Did it give them a deeper understanding? And did it enhance their interest in the topic? And what we see is that across all three questions, the proportion of students that said yes to each question was highest for the platform face-to-face format. In other words, this suggests that students seem to prefer the platform face-to-face format. So putting all our results together in conclusion, we've provided novel evidence on how the delivery format for gamification impacts on students, and our key message is that our results suggest that the platforms are good, they work well, but they work particularly well when they're used under face-to-face delivery. However, we should also highlight that the other thing we've shown is that these type of games, which involve students making individual choices, can be delivered under asynchronous methods, and if we do that, we're still able to achieve the learning outcomes. It would be really interesting to generalize these results across a range of other games and a range of other institutions. Thank you very much for listening to our presentation.